So we're going to do a twin. I don't know how much of this I'm going to do because I have another video I got to get done today. But I figured I'd go ahead and start on it. And do make sure that you can do everything by hand. Make sure that you can, unless I do like a Y1, Y2 thing, make sure you can do it by hand. All right. All right. Given log base 2. See how I read that? I read that as log base 2. And I usually say in class argument 32. Now, what's it asking? The question is the base of 2, so what power of 2 equals 32? And you're supposed to be able to figure that out in your head, right? It's not a hard question. I mean, everybody and their mama knows 2 times 2 is 4, right? 2 times 2 times 2 is 8. You see where I'm going with this? So 2 times 2 times 2, that's 8, times 2 is 16, times 2 is 32. So the answer is 5. That's the answer. The answer is not 2 to the 5th. The answer is 5 because it took 5 2's to make that happen. All right, the next one, given log base 10. Now, if a base is not given, it is understood the base is 10. So it's kind of asking the same thing as the last one. It says, what power of 10 is equal to 1,000? Well, kids, that's 3 because 10 times 10 times 10 is 1,000. So the answer is just 3. All right, what is the domain of the natural log of 3x minus 5 plus 4? So there is a rule that you have to memorize. And I'm trying to remember if, surely this is in your notes by now. If not, it will be at one point in time. For any logarithm with an argument, the argument must be bigger than 0. It's kind of like your square root rule. So the argument of this natural log is 3x minus 5. So 3x minus 5 has to be bigger than 0. Well, that's a 2 move, right? We add 5 to both sides and we divide by 3. So x is greater than 5/3. That's the domain of this thing. Now, it just depends on how you want to write it. You could write it one or two ways. You could use good old classical, old school set builder notation. And set builder is old school, by the way. And, my kid is only in first grade. He understands inequality symbols. Why don't my juniors understand inequality symbols? That blows my mind. Blows my mind. Or, and some of you juniors do, parentheses on the 5/3 because there's no equality. And then you run right forever to hit infinity. How I represent it, couldn't tell you. All right, find the inverse of f of x equals log with an understood base of 10 because it wasn't mentioned. And the instructions are right here. Swap x and y, resolve for y by converting to an exponential form. So if you see f of x, you've been told this, you get the f out of it. Everywhere you see a y, remember it is y too, that's why we do it. And everywhere we see an x, we become a y. Now we're going to do the easy moves. The easy move is to add 5 to both sides. X plus 5 is a logarithm of base 10 whose argument is 2y minus 3. You need to learn to speak the way I speak. It's part of it. Now, you're supposed to have memorized that a logarithm of base b, argument a, equal to something is equivalent to a base with an exponent equal to the argument of the old logarithm. So we're going to go through and identify our pieces, okay? This 10 is a base. All of this would be the argument of the logarithm, which means that all of this is an exponent. So our conversion here, we have a 10 for a base. She is raised to the x plus 5 power, and she would equal twice y minus 3. 2 moves and you're done. First move, add 3 to both sides. 10 to the x plus 5 plus a 3 is twice y, and divide out the 2. Now, since that isolated y, 10 to the x plus 5 plus 3 all over 2 is going to be the inverse of f of x. All right, got another one right underneath it. Find the inverse of f of x equals 2 times 10 raised to the x minus 2 plus 4. And we'll just go through and we'll do our first step. We'll swap x and y. Last year's group did so phenomenal on this. They really did. So be better than last year's group. All right, do your easy moves. You can subtract 4. And you can divide by 2. And we're trying to get it down to where the base is isolated. That's what you want to get down to, is an isolated base. 2's cancel. So x minus 4 over 2 is 10, and that 10 has an exponent of y minus 2. Now, go back to this. This is a base. This is all the exponents, which means that this is going to become the argument. You see down here, bases have exponents that equal the argument of the logarithm. So you're going to do the conversion from exponential form to logarithmic form. So we're going to have a log whose base is 10. Her argument is x minus 4 over 2, and she would equal y minus 2. We're going to add the 2. And that is going to become our inverse. You need to get down inverses. The first test will be kind of rough, but by the second test, I think it'll be pretty good. Inverses are not that big a deal. I will be right back. So at least in class, you guys acted like you appreciated these. You could do them. We'll find out come test day, right? Compounded quarterly tells me that I'm going to be using the formula for compound interest. So the amount after time passes is the principal times 1 plus the rate of interest as a decimal over the number of times the interest is compounded per year, raised to the number of times that interest is compounded per year, times the number of years it takes to happen. So you are going to invest $50,000. That is your principal. 1 plus 12.9 is 0.129. You shift that decimal once, twice. Over n, quarterly, n is 4, and your exponent is going to be nt, so 4 times 20 years. And then you push buttons in a calculator, and it gives you an answer. So let's see what the amount in 20 years is. There will be some kids, the first time they have pushed the buttons to do this is test day, and you will fail because you don't ever play along. And you will pester Milbrath about what you can do to pass my class. And you can start doing the things you're supposed to be doing. I am not going to baby you. You're not my flesh and blood. And even if you were my flesh and blood, I still wouldn't do it. There you go. $633,521.46. 633,521 and 46 cents. Pretty cool. 12.9% interest. You borrow every dollar you can and you invest. What rate of interest is required to quadruple, which means that you multiply by 4, an investment of $20 in 8 years if interest is compounded continuously? So our formula here, because I saw the keyword continuous, is PERT. Now this is your principal. If you quadruple it, the amount after time is going to become 80. Remember, E is just a button, it's just a number. And I don't know R, but I do know the time. The time is 8. I'm going to do this 2 different ways with you. One of the ways I'm going to do it is with logarithms, and the other way I'm going to do it is y1, y2. But, so we'll just kind of starve this. I'll come back to this in a minute. We're going to divide out the 20. That's going to give me 4 because it quadrupled. 20's cancel. It'd be equal to e to the 8r. Now I'm going to do the logarithm conversion. Remember, log is bay. Log is bay. Bases have exponents. So label your things. You're going to have a log whose base is e, its argument is 4, and it equals 8r. Now log base e is the natural log. So the natural log of 4 is 8r. So r is the natural log of 4, sitting pretty over an 8. And that's a valid answer. That's 100% a valid answer. I might put that as an answer choice just to see if you know how to do logarithms. Now let's see what that is, because I'm going to compare and contrast to doing a y1 and y2. So the natural log of 4 over 8 is 0.1733, or 17.33%. Now, I went and talked about this up here. You know, what I could have done is I could have done a y1, y2 situation. If I could get that far, I could probably save my skin by doing y1, y2. Cool, I already had an 80 there. So we got 20. The E key is second ln, and the exponent is x times 8 or 8x. It doesn't really matter which type. You can type x, but probably put that 8 instead of parentheses. Zoom 6, that's what you were taught to do. You're going to play with your window. You got to look 80 units in the sky, right? And there's enough time that's passed because it's 8 years, and the x-axis goes out 10 to the right. So let's look 100 units in the sky. That's your y max. Oh, sorry, the x-axis here does not represent time. It represents the unknown, which is the rate. And it's still there. Second trace, 5, enter, 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 bam, 0.1733, just like I told you. Now, for me, it's quicker to do these things by hand than it is to mess with a graph. All right, solve 1/4 to the negative x plus 5 equals 64 raised to 2x minus 1. You have a property. It says if x to the a equals x to the b, a is equal to b. But these two pieces must match. That's the deal. They have to be the same. If they don't match, it ain't going to work. Now, I know a little something about exponents. I know that 1 over 4 is exactly 4 to the negative 1 because I understand negative exponents. Judging by the quizzes I've been grading thus far, a lot of y'all do not. But I know it, so that's how I'm going to do it. Now, I also know that 4 cubed is 64. Shame on you if you don't. So I'm rewriting the numbers in terms of being 4 so that I can use this property. Now, I already had a 2x minus a 1 in the exponential space here. And over here, I had a negative x plus 5. And I've got to put those guys in their exponential space. I'm going to go ahead and distribute before I clean this thing up. But a negative 1 times negative x plus 5 means that that 4 is raised to the x minus 5. And if I distribute that 3, I'd have 6x minus 3. Now, since the bases are now the same, I can chunk them. And I have the equation x minus 5 equals 6x minus 3, which is an Algebra 1 question at best. It's an 8th grade level question, to be honest with you. We're going to subtract x. I'm going to subtract x from the right, and I'm going to add 3 to the left. Negative 5 plus 3 is negative 2. And then I divide out my 5, and I get that x is negative 2/5. Easy peasy lemon squeezy. Number 9, solve 3 times e to the negative 7/10 of x plus 3 equals 33. And it says get it into the base equals a form before converting to a natural log. So you have a giant hint there, because what you always want to do is you always want to isolate bases. And this base over here of e is not alone. You need to subtract 3. That'll give you 30. You'll have 3 times e to the negative 7/10 of x. Then you can divide out your 3. So e to the negative 7/10 of x is actually 10. And now we're going to do a conversion. And I'll write this down for you again. A logarithm base b argument a equal to e has an equivalent inverse of a base with an exponent equal to the argument of the logarithm. Log is bay. Anywho, this is my base. This has to be an exponent because bases have exponents, which means that this guy has to be my argument. What you'll find here is kids don't even know what part of a number represents the exponents. How are you going to be a junior and you not know what an exponent looks like? I don't know, but it happened. I have a logarithm whose base is e, her argument is 10, and she equals negative 7/10 of x. Now, Clear the fraction. There's lots and lots of ways of doing this. I'm actually just going to multiply both sides by -10/7. That's going to cause the 7s to cancel, the negatives to cancel, the 10s to cancel. So -10, and this is a log base e. Remember, log base e is the ln. -10, natural logs of 10, sitting pretty over 7 is my answer. It says write it in exact form. Now, I will probably give half credit for a calculator answer. And let me talk about that. So I'm not going to write that down, but I will probably give half credit for a calculator answer. So if I had no idea what to do, I could have at least done this. I could have typed into y1 3e to the -7/10 of x plus 3, and then a y2 put a 33. Zoom 6 it. I'll play with the window. I'm going to have to look up at least 34 units. You know, something above 33. I'll just do 40. That'd be a Y max adjustment. And I feel like a standard left and right 10 is probably going to do it. Should, because I was seeing exponential decay, which means it rose really quick as you ran left. All right, an intersection has been found, unless you've been living under a rock like Patrick. It's second trace 5. Shame on you if you hadn't figured out second trace 5. I mean that. Shame, shame, shame. It's time for you to fix your issues, because you can fix your issues. And it's like -3.2894. -0.32894. I wrote that wrong. -3.2894. Now, is that the same as what I wrote? Well, what I wrote's perfect because it was not rounded. But let's see if they are the same decimal, and they should be. And this is also a very good way to check yourself. It is. Think about it like that. If I want to know I'm right, can I compare and contrast to a graph? And by golly gee, wow, I can. So again, I'll probably give half credit for this, but it all depends on if I remember to or not, to be quite honest with you. All right, what do we got next? 10, which is where I'm going to stop today because I still need to do a homework video and a lecture video at some point in time. Solve log base 4, argument 2x minus 5 equals 3. Give your answer in exact form and as a decimal rounded to the 10,000th position if possible. So let's see what happens this one. And again, it's all about log is bay. Log is bay. Just stick with that and trust me on that one. Base, argument, exponent. 4 cubed must equal 2x minus 5. 4 cubed has always been 64. We're going to add 5 to both sides. 69 is twice x. And then that makes x 69 over 2. Now, 69 halves is not a decimal that you can round to the 4th decimal place. 69 over 2 is literally 34.5. Easy peasy, lemon squeezy. And yeah, I'm going to stop there for right now. Maybe I can do some more tomorrow.